Welcome to the second talk of our day. Nekola Nováková, will tell us about communication of astrobiology and astrobiological topics and some tricky parts of this issue. And we are very glad you came to our public outreach day of our Drake workshop. And if you have not done it already, you are very welcome, and we will be very glad if you fill in our questionnaire that is pointing to the Drake equation and how people understand it and what are the factors that in fact affect our estimates of the number of intelligent civilizations in space. But now, without further delays, Julie, you can start. Maybe just one last sentence. Julie works in Institute of Physics here in Czech Academy of Sciences now. So he is a local Prague astrobiology specialist.
And I'm partly here at the Faculty of Science in the Drake project. So anyway, thank you for coming. And in the previous talk, Peter mentioned more the latter parts of the Drake equation. And in my talk, not just on astrobiology outreach, but also direct exercises within it, I will focus more on the terms of the fraction of planets suitable for life and where life actually appears. And for that, we can start with our neighbor, Mars. Okay, so which ones of you are dreaming of one day leading a space mission or being part of it? Okay, yes, about half of you. But I guess that all of you probably led some project in the past or created something that was your passion, that you wanted to see to a successful end. So let's start with a story. Imagine that you are the leader, the principal investigator of a space mission that's on the way to the red planet. And it's on the way there to search for life. Because on Mars we have searched for life multiple times, and we know that in the past there were conditions for life. There was flowing water that carved these channels and deltas. We can see a suspected line of a seashore, but we are not sure of how long-lived this liquid water on Mars was and whether it was there for a prolonged period of time at the beginning and then it just stopped because the atmosphere was too thin and it got too cold, etc. Or whether these time periods were sort of more distinct. We want to learn, and that's why we are going there. Right now, rovers such as NASA's Perseverance are investigating the past conditions for life on Mars and even potential traces of life. As we have seen about 2 weeks ago, these are the so-called leopard spots. And in these spots, you can see minerals that have different redox states than their surroundings. And here on Earth, these minerals are being often produced by microbial life. The question is, was life what produced them on Mars, or was it some other source? Because we can think of conditions completely independent of life that could produce them. So it's not a definitive biosignature, but it's a promising potential one, and we definitely need to learn more. And that is why you are sending the new space mission to Mars, something akin to Perseverance, which you can see here, but equipped with more experiments and with more instruments. Have you heard of the Viking probes in the 70s? Some of you did, some of you didn't, so I will very briefly introduce them. These were quite ingenious landers developed by scientists including the famous Carl Sagan. And they were quite unique in that they included not just instruments, let's say, to analyze the composition of samples or image them to see if there are interesting structures, but they included biological experiments. They took samples of the Martian regolith, let's call it soil, although that term is usually reserved for something with life already in it. And they put it through multiple experiments where they added nutrients, added water and more to see whether there are some microbes that could be photosynthesizing or which are heterotrophic and could be consuming the nutrients and releasing carbon dioxide. And the carbon in these nutrients was radioactively labeled so that they could see if anything interesting happens. And in one of the experiments, it did. In the so-called labeled release, they really detected on both Viking landers, not just one of them, release of this radioactively labeled carbon dioxide. So was something eating these nutrients? Was there life near the surface of Mars? It sounded a little promising, also because the negative controls, which had completely sterilized Earth samples inside them, came up negative, so the experiment seemed to be working. So what happened? And your job is to try to find it out, because you are not only sending a rover with the capabilities of Perseverance or the upcoming ExoMars rover, but also trying to replicate the labeled release experiment with samples from a greater depth where there could be more intact signs of life or less probably even life itself. So obviously, you are very excited about your space mission. You spent years working on it. It was teamwork which included many, many dozens of people working on it day and night, coming up with these instruments and analyzing data, testing here on Earth. It was worth several $100 billion. And now, while it's on the way to Mars to land there in a couple of months, you have a problem. Because there was a routine sweep of one of the clean rooms where the spacecraft was assembled after the individual parts were sterilized. You might ask, why were they sterilized? Any ideas? Why would you sterilize a spacecraft before sending it to Mars? Exactly. We don't want to contaminate the red planet. A, because if we bring Earth life on the spacecraft, it could contaminate the results of these experiments and instruments. We could be trying to detect Martian life and instead detect traces of Earth life. So this beautiful mission that has been the work of so many people and which costs so much would be worth basically nothing in the end. So you definitely don't want to do that. And you also don't want to do that because you might be afraid that the Earth microorganisms, which it might be carrying, could potentially survive on Mars. Not likely on the surface. The atmosphere is too thin, there can't be any stable liquid water, and there are many chemical extremes, temperature extremes. It's not conducive for life. But in the subsurface, there could still be, in some places, clement conditions for life. We just don't know yet for sure. So you definitely want to avoid bringing hardy Earth microbes into these environments where your rover will be drilling. Hence the problem, because the routine sweep of the clean room returned new species that wasn't previously found there. It hasn't been sequenced, it's hard to cultivate, so you do what you can to learn as much as possible about it as quickly as possible, because it might have been there when your rover was assembled. And if it was really there, it's possible that it's carrying these microbes on the way to Mars. And if they are somewhere slightly protected from the vacuum and radiation of interplanetary space, they could survive the journey. They could survive the landing. And what if they could survive on Mars? I mean, your mission would be compromised, but possibly all of future research of Mars could be compromised. That's why we have the so-called planetary protection, basically trying not to contaminate other space bodies, especially where life could potentially survive in some places. So now you have to make a decision. I mean, it's not just you. There is the Planetary Protection Committee, which gave the recommendation to abort the mission, to not let it land on Mars. But it's a recommendation. And higher-ups also issued some recommendations, but in the end, in this case, the final decision is up to you. So do you risk bringing something like this is our good friend Deinococcus radiodurans, to Mars and continue with your mission, which might not be contaminated at all? Or do you abort the mission? Do you lose all these years of work, all this money, and basically maybe any chance of putting these instruments and experiments on Mars? Because space agencies would be unlikely to pay for the same rover twice. What would you do? Any takers? Who would continue with the mission? Okay, a few people. Who would abort the mission? Okay, slight majority. Anyone who's still undecided? Yeah. And what would you need to know to make a decision?
I don't know. Maybe, I don't know. It's complicated.
Exactly. I mean, it's an answer without one clearly right answer, because there are so many of these I don't know. There are both known unknowns. I mean, we know that we don't know whether the spacecraft was actually contaminated and how many spores of this microbe could be on it. We don't know exactly what kind of conditions it can survive in, because the research is still ongoing, and although we are trying, we can't hurry it up too much. And there might be some unknown unknowns, questions that we did not think to ask at all, which might prove important in the long term, but then it might be too late. So this story is just an illustration of the dilemmas and questions that we might encounter very possibly in astrobiology in the near future. And it's also a story that's part of one of the outreach anthologies of the European Astrobiology Institute. So I started with this story to show you how immersing yourself in a character, in some kind of dilemma that the character is facing, living through the hard decision, can make people dive more into the otherwise more abstract scientific questions, like, well, why is planetary protection a good thing, and to what extent we can make sure that a spacecraft is really completely sterilized before sending it somewhere. The answer is basically it's never completely sterilized, but we are trying. And, starting with this story, we can dive into the issue of extremophiles. What are the extremes in terms of radiation or temporary lack of water or chemical extremes that life on Earth as we know it can still endure. And that was the rationale of these outreach anthologies, to use science fiction stories, mostly plausible stories or some of them far more speculative, but all dealing with some topics from astrobiology, be it planetary protection of Mars or the history of Venus, where the questions are basically never ending. We know so little about what conditions were on the surface of Venus in faraway past, whether it had liquid water oceans or not, and if so, how long? No idea. That's why we're sending the missions like Veritas and Da Vinci and Envision. Hopefully at least Envision is going to fly. About the American missions we shall see. But the point is that the story can make people engage more with the questions and with the topics, and hopefully also inspire people to go into research or just plainly take an interest in science and feel the curiosity that is at the heart of what scientists do. So there are two of these anthologies. This one is available completely for free as an ebook. That was sort of proof of concept. This one is available in print. There's more information about it at the European Astrobiology Institute's website. But the question, of course, is to what extent can science fiction be used to let people ask more questions, dive deeper into astrobiology and other scientific topics, or to be inspired for science careers? I mean, we can use science fictional exoplanets to talk about real exoplanets that have been discovered. Do you recognize this one? Which one's it?
Star Wars.
Yes, it's from Star Wars. It's Tatooine, Luke Skywalker's home world, or rather where he grew up. And what's interesting about it is that it orbits two stars. It's what we call a circumbinary planet. You know, if you encounter the term circumbinary planet somewhere, it's kind of abstract, it's not that catchy. If you start with the image of Tatooine, which most people saw, then suddenly it sparks more imagination, and we can dive into, again, more questions like how stable are the orbits of these planets in the long term? Could many of them be habitable or not? How is their eccentricity, you know, how oblique their trajectory is changing, and more, or how the spectral types of these two stars, if they are very different, could change the habitable or uninhabitable conditions on the planet itself. So it's basically a discussion starter. And do you remember what were the first confirmed discovered exoplanets? They were quite exotic. Exactly. They were, it was a planetary system around a pulsar, a stellar remnant, basically a dead star that went supernova. It had been very massive, and the remnant of that supernova explosion was an extremely tiny star. Imagine it the size of Prague, some 10 to 20 kilometers across. But it's an extremely dense object because it's still far, far more massive than our planet, all compressed in this tiny diameter. And around this planet, around this star, the product of a supernova explosion, 3 planets were discovered. They are quite exciting. We know extremely little about them. We know the orbits, we know the masses, but what could be the conditions on them? How did they originate? Did they survive the supernova explosion? were they formed afterwards from the debris in falling onto this remnant star? We still don't know. And what can inspire this discussion are, for instance, the pulsar planets in Midnight in Doctor Who. And in terms of exotic life, there are so many life forms in science fiction that we can use as discussion starters. I mean, within the narrower workshop, like the narrow circle, Tom mentioned this 2 days ago quite extensively, so I won't go into so much detail. But this is an amateur fan depiction of Rocky in Andy Weir's project Hail Mary. We'll see whether the movie nails him, but it's definitely an exotic life form which also lives on a super-Earth planet whose properties are quite realistic given of what kind of planets we have been discovering so far. So again, a good discussion starter, and we can see lots of science fiction being even mentioned and referenced on conferences. This is from the International Astronautical Conference last year in Milan. There were science fiction cartoons, Daniel De Paulis talking about Solaris, etc. But is science fiction really effective in inspiring people to go into science? Luckily, we have some data for that. Here you can see results of 2 surveys of British and French astronomers by Elizabeth Stanway and, in the case of the French, by Boissier. And on the left, you see the level of adoration or liking of science fiction. And you see that it's very similar in case of both the British and the French astronomers. The French are in the blue columns, the British are depicted by the red stars. And you see that both groups have expressed quite high liking of science fiction. But it's interesting to see the difference in case of the variable influence, to the extent of what they were inspired by science fiction to pursue a scientific career. And for the British, again, the red stars, you see that the influence level is quite high. Science fiction has been, in their own consideration, an inspiring factor for them to follow a scientific career. But for the French, the results are quite different. The distribution is more uniform, with the largest number of people being inspired either very little or not at all. So there are definitely some interesting cultural differences. We cannot say that science fiction in general for everyone can be an inspiring factor to go into science. But we can see that it is working in some conditions, in some cultures, and it would be definitely interesting to learn more, to get data from other countries. Nowadays, you can see, if you're interested, lots of resources of science fiction with good astronomy and astrobiology and other related fields. This is a list compiled by the American astronomer Andrew Fracknoy. There are papers on using science fiction for teaching, not just science, but also humanities, because these 2 researchers from the University of Arizona are using Mars literature like Kim Stanley Robinson's Mars trilogy to highlight social issues here on Earth. Because science fiction can be really good for it, extrapolating the social problems that we have today and making them more apparent in fictional settings, let's say in a new society on Mars. Like Peter mentioned, we often envisage future space settlements as a kind of utopia. But would they be? I think it's not as likely as we would love it to see. And these kind of classes also highlight that perspective. And of course, books like The Martian also came in educational editions with exercises and questions for teachers and their classes. Also, strangest of all, the first AI anthology also has teacher and class questions and exercises. And we can also look at whether science fiction is portraying the science somewhat realistically or whether it's very far off the mark. And one researcher, formerly at St. Andrews, now at Open University in the UK, Emma Puranen, was interested in looking on how exoplanet portrayals in science fiction changed since the actual exoplanet discoveries, from the first confirmed pulsar planets at the beginning of the 1990s up to today, when we have over 6,000 confirmed exoplanets, and the number is still growing, and there are many candidates waiting to be confirmed with more observations. So we have done quite a lot in the past few decades. So does science fiction reflect this, what we have learned about the distribution of sizes, about the variety of orbits they can occupy, and about that many of them might not be habitable but are still extremely interesting. And basically it does, but not so much. We can see a decrease of habitable planets in science fiction in the past approximately 2 decades. We can see an increase of interestingly portrayed uninhabitable planets, stuff like gas giants or super-Earths with poisonous atmospheres, high pressures. The list goes on and on. So these worlds are extremely exciting, and it's exciting also to see them actually portrayed in science fiction literature and books. But to return more to astrobiology outreach, a little bit further away from the science fiction possibility of using it for outreach, we also have this cards on planetary habitability, which is a work in progress. It had been used with only 3 classes so far, and it's an exercise for children, ideally aged between, let's say, 9 and 13. Hasn't worked so well for older kids yet. And in these cards, each group of kids has several possibilities on what kind of star to pick for their own planet to sort of construct, or what kind of planet to pick. So they can pick a gas giant and its moons. In our solar system, we do know moons with extremely large water oceans, but these are locked under their icy shells. There are moons like Europa, Ganymede, in case of the smaller ones, Enceladus, etc. The list also goes on. Or they can pick a more straightforward Earth-sized rocky planet, which, depending on what kind of star they chose and what kind of other traits like the orbit they discussed, could end up more like Venus or more like Mars than our actual Earth. So it's a nice way to discuss the many factors that go into habitability, and we would like to storyfy and gamify it more in the future. So before we dive into the discussion, I would like to thank the 4EU Plus Drake project, which supported this meeting. And I would like to ask you again to participate in the survey. In the afternoon, you will hear more about things that are directly related to the survey. So if you want to fill it in, now is a great time so that you are not influenced by the afternoon talks. And also, there's going to be a lunch break, so there's plenty of time to participate in it. But now I think there is plenty of time for your questions and ideas.
Thank you very much. So, do we have any questions? I do. If you are not eager to, I will ask. Why do you think that some scientific cultures might be more inspired by sci-fi, whereas others are more reserved towards it? What's your theory?
That's an extremely interesting question. And I mean, without data, we can't really say for sure. But I would say that the current present-day British culture is more steeped in science fiction than the present-day French one. Because although the French have the tradition of Jules Verne and they have several large conventions that are happening there each year, there are many more conventions in the UK, and they have ongoing series like Doctor Who, which has about 70 years tradition. And I think it's just more prevalent there. It would be really interesting to see what the results would be for Czech astronomers, and I'm planning to hopefully introduce it at some future conferences. So then we might be able to see, because here I think science fiction is not as prevalent or like adored in the UK, that we might be more comparable to France. But on the other hand, you know, from anecdotal evidence, if I talk to astronomers or geophysicists, you know, people in the sciences working with space in one way or another, many of them do like science fiction and they expressed some kind of inspiration. But yeah, it's all just anecdotal. Might be really interesting in China because, I mean, for a long time, there was no like big boom of science fiction literature or movies. But in the past 15, 20 years, it's skyrocketed, and the Chinese government is actually supporting science fiction writers as a form of ideation for companies and for sciences. So it is quite popular and actively supported there. And, you know, might be some interesting differences between older and younger Chinese scientists, but that's all just pure speculation on my part right now.
But anyway, thank you very much. Any other questions? Okay, first two, then Nana.
I have just one remark as concerned the French astronomers. Because I remember when I was at Eurocon, I think about 10 years ago or something like this, and I discussed with participants from France, and they told me that science fiction is not taken as a serious thing as concerned academic research. Because in UK and especially USA or Canada, it's just normal that there are many scientific papers about science fiction literature, science fiction films, and hundreds, maybe thousands people deal with the problems. But French people told me that for French academicians, science fiction is not serious. It is not a topic for research. Maybe now it's changing. I don't know, but it's maybe 12, 15 years ago they told me that.
It's interesting. Thank you.
Hi, thank you very much for your talk. I think it's such an interesting topic, not the overlap, but the interactions between science fiction and science. And I think it's so important also to remember, as you're saying, like our role in doing outreach and like how we can use science fiction in that. Do you think, you mentioned again the interactions, how science fiction can affect research and how research can affect science fiction. Do you think there is a difference in the science fiction written by scientists and non-scientists? And what do you think that the main difference there would be?
So, I mean, from my experience, again, not supported by hard data, I think that scientists are more prone to writing, let's say, scientifically more plausible science fiction. And if we look at authors like Alastair Reynolds, whom I mentioned, and who is an astrophysicist, his space-based science fiction is sometimes very wild, but still imaginable from the astronomy point of view. And I know biologists who are writing biotech-focused science fiction, but then again, there are many authors without any background in the sciences who also write this kind of so-called hard science fiction, you know, more grounded in science. And there are also authors who are who have day jobs as scientists, who are writing basically fairy tales set in space, more like Star Wars. So I would say there is a correlation, but it likely wouldn't be a strong one. Again, that's an interesting question to dive into, maybe with Emma, whom I mentioned. And yeah, and I think it's also interesting in, you know, a related question to realize the potential pitfalls of using science fiction in outreach, because if we focus very much on it, then people can get the impression that what has been presented in the science fictional part is the reality, which is very far away from it. So we have to be careful about the distinction, about the wording, but I think it's still an effective way of outreach.
Okay.
Hi, Julie. Thank you so much both for the content of your presentation, but I think also the format was excellent. I very much liked how you took us on a journey in the beginning part. To maybe no surprise, I have a question about cultural identity, but it's a personal one as well. I'm wondering, given the geopolitical history of your home country and the institute that you're presenting and that we're all here together today, do you think there's a different view and different lessons to be learned, especially consider that you would draw upon Western and then former Soviet science fiction resources? And do you think that still has an impact today on how science fiction is being perceived and maybe also created here in Czechia?
That's an extremely interesting question. So it's my impression that nowadays Soviet... Oops. Oh my God, I'm so sorry. No, if you don't, yeah, I'm gonna wipe it later. No, it's okay, I'm gonna do it later. I don't think that it's widely read, especially among the younger generations nowadays. What is most read is Anglo-American science fiction. Czech science fiction is also very popular. And then there are very few works translated from other languages than English being translated and published. I mean, we had a Czech translation of The Three-Body Problem, which was originally published in Chinese. We had some books translated from German, etc., etc. But the majority is Anglo-American. And if we also look at like lists of recommended reading for students and for children, we don't see that much science fiction on them. It's more focused on like realism. And if we see any science fiction, it's usually more contemporary Czech or Anglo-American one, very rarely Soviet or Russian. There are extremely interesting works, like especially Strugatsky's novels, and I think that from the former Eastern Bloc, Stanislav Lem, who was Polish, is still the most popular author, and people still read Solaris and Invincible, but I would say it's not canon anymore. Let's say 20 years ago, if a person was a science fiction fan and they haven't read Clarke, Asimov, and Lem, they were considered to be weird. You know, what kind of science fiction fan doesn't read these classics? And the landscape has changed quite a lot because also more diverse literature is coming in. So, yeah, I don't think that like former Soviet science fiction has that much influence or has had it ever since the Velvet Revolution.
Yes, thank you. Do you think that the people who are writing now in contemporary Czech science fiction, who are still part maybe of that influence sphere of the former bloc, incorporate some of the ideas at least, even though it's not explicitly referenced?
I think they rather oppose themselves against it.
Okay.
So more like ideological science fiction has never been that popular. And before the Velvet Revolution, there were many fanzines being published, like semi-secretly, some of them more in the open. But the kind of stories that were published there were either like too detached from the real world or in a veiled way opposed to communism. And most of the authors who published in them in the 80s and are still publishing today are opposed to the ideology. So I wouldn't say that it has like lasting impact.
Okay, thank you.
Okay.
Yeah.
Okay. Thank you for the presentation. There was interesting part of this change of portrayal of exoplanets in science fiction, and I was wondering if there is some change in portrayal of extraterrestrial life, since now astrobiology is a true science, so it must stay sort of grounded. But this fiction part shall, in my opinion, explore the new science-based possibilities where to place the planets. And I was surprised that there was actually more percentage, if I understood well, of the description of uninhabitable planets. They'll see if there is if you know about some work, or since you are writing and reading a lot of contemporary science fiction, is there some kind of shift of this boring anthropocentric chauvinism that yes, the life is more or less humanoid, or at least human-sized, or at least living in this room temperature plus minus 100 degrees C, it's carbon-based, and so on and so on. Do you see some trend to somehow take advantage of having a science-based new environments for life to describe in science fiction?
So that is actually a question I want to dive in, possibly with Emma, although she's now in more like ethics of space sciences department at the Open University. But I have been wondering this as well. But if we look at famous examples of exotic life, they come from different time periods. It's not just recent works. I mean, if we look at the dragon's egg and the Chela living on the surface of a neutron star, that's extremely exotic potential life depiction. And it was published in the 80s, I think 81, something like that. if we look at Fred Hoyle's black cloud, that's the 60s, if I remember correctly, basically a living molecular cloud. So these exotic life forms have always been part of science fiction literature. And nowadays we can think of examples like Rocky from Project Hail Mary, or the Stellivore microbes, also from the same novel. There are some exotic aliens in the novels by Alastair Reynolds, and Becky Chambers has a really interesting novella called To Be Thought If Fortunate. So the life there is, let's say, more Earth-centric in that it's carbon-based and using water as a solvent. So, you know, the kind of life forms we most expect to find somewhere. But it's not anthropocentric in, you know, not making the planets about having survivable conditions for humans specifically. I think there is a shift from planets that are survivable by humans. I'm not sure if there is a recent shift towards more exotic life. And yeah, you know, it should be explored with some, you know, set corpus of works that have been published in each decade to find out whether this is the case or not.
Thank you.
And yeah. Oh yeah, I was just about to add that in a similar vein, it could be interesting to look at the portrayal of SETI, because today is focused a lot on the Drake equation and stuff like the Fermi paradox, you know, where are they? And we can see lots of SETI and, you know, communication-focused works starting in the 60s after Project Ozma. Then they gained popularity again with Contact by Carl Sagan in the 80s. And nowadays, I don't think that we see so many of them. I mean, we see communication-heavy novels that are not necessarily focused on detecting a transmission, but rather communication directly, like The Story of Real Life or Arrival, the movie adaptation. So yeah, that would be also interesting to look at.
Okay. First of all, I want to thank you for your enthusiasm, the way you presented things. And it's a communicative enthusiasm, in fact. So you are doing it pretty well. Now, I have a few comments about several topics you touched. I don't want to be long because it's more or less lunchtime. First of all, about the relationship of science fiction. There was a long period where science fiction was ahead of science. This happened in the late 19th century, early 20th century. And this is why those authors, like Verne to some extent, but mostly Wells in Great Britain, inspired so many people, including scientists. Freeman Dyson, for instance, recognized Freeman Dyson is a well-known physicist, one of the greatest physicists of the 20th century. He wrote about the Dyson sphere. He was inspired about another guy who is very well-known, Olaf Stapledon, a major figure of science fiction. Okay, so this period was until the Second World War. After that, there was an explosion in our understanding of the universe. Science discovered objects that science fiction authors could never dream of. Pulsars, black holes, quasars, and now exoplanets. Very different from what any science fiction author could ever imagine. And now science fiction authors are behind science. They're running after that. As you said, now they are trying, after all those exoplanets that have been discovered, they are trying to be in conformity with those exoplanet settings. In the old days, when Edgar Rice Burroughs put men on Mars, or even other creatures on Mars, nobody cared to know what are the real conditions on Mars. And even Wells, he put extraterrestrials on Mars for the War of the Worlds. Now nobody would dare to put not extraterrestrials, but even microbes on Mars, because we know they are not there. And the same thing now is for the whole solar system. Nobody would put extraterrestrials in the solar system. I don't mean microbes. No, microbes, nobody cares for science fiction. I mean, unless if you can imagine a threat from microbes creating an epidemic. So this is for the relation of science. I think from now, science fiction will be very much in difficulty to propose things that are not in conformity with science. And there is a shift also because from the 60s, okay, the development of science after the Second World War was such that in the 50s and 60s there was a huge enthusiasm. In one decade we mastered computers, nuclear energy, and space flight. And this opened a new world for science fiction, to imagine things. That's why this is the golden age. Asimov, Clarke, and so on. Everybody was thinking that we shall go in space and we shall find extreme things. But from the 60s on, there is a downturn because people realized that science make also very bad things. And so there was a shift in science fiction from one thing. Then it was the end of the Apollo project in '72. And the dreams for space were now falling back. Nobody would think. Some people were thinking about those things, but the initial enthusiasm is not there anymore. And I don't think it will come back from science fiction. But on the other hand, there was a lot of science fiction, as you mentioned, Kim Stanley Robinson made fantastic work for, and this can be used for educational purposes for sure. That's how I learned a lot of things on Mars, because I'm not a planetologist. Anyway, I don't want to speak very long. Just one last thing between French, the difference between French and British, because I noticed that. I'm coming from Greece, so but I spent 40 years of my life in France. So I know about French scientists. In France, it's probably one of the countries which are more Cartesian in the world. There is the Cartesian spirit. People are much more rational than anywhere else, I think. They have this logic. I mean, they believe in things. The Anglo-Saxons always had a rather different culture, which is reflected in science fiction especially. In the words like, in people like Wells, Stapleton is the archetype of that. He could imagine, the Anglo-Saxons can imagine on a very big scale. The French people do not imagine. Is it perhaps because they had an empire, a huge empire over the world? But they think big, and they have this tendency to, this is reflected in their science fiction, about galactic empires, what Asimov did in the United States and so on. They think in very big. The French never did that. They don't think in... And I think this is the most important difference between French culture and British culture, for different scales.
Yeah.
Yeah. Okay, thank you. It was very long.
Thank you. Yeah, that's a very interesting insight. But as to science fiction being ahead of science previously, you're right in many aspects, but I don't think the example of Mars works, because what Wells did was to create Martians that were plausible by the scientific standards, by the scientific knowledge of Mars in the late 19th century. Because still many scientists thought that Mars had been habitable previously, and it might be nearing the end of its habitability, but there might still be life. So Wells's Martians were plausible, were in accordance with science of the late 19th century. And even in the early 20th century, Wells wrote several popular science articles describing how life on Mars could look based on the conditions, based on the lower gravity, thinner atmosphere, lower availability of water. But at that time, we had no idea that the atmosphere is so thin that there can be no stable liquid water on the surface. And in a similar way, Venus was considered habitable by many astronomers up until almost the middle of the 20th century. I mean, from the 30s, we knew that carbon dioxide is the primary constituent of the atmosphere, but we did not know about the actual density, the pressure at the bottom of the atmosphere, and most importantly, the high temperatures. So many people considered Venus to be potentially habitable, not necessarily for complex life, not necessarily for humans, but habitable. And this view was only changed by the Mariner flyby, was it in 62, I think, or 63, at the beginning of space exploration of the solar system. So even then, lots of science fiction was considered to be scientifically plausible. And maybe what is considered to be plausible today, like many of the exoplanet portrayals, will prove to be far more grounded in fiction as we will learn more about these planets.
No, sorry, I think I was misunderstood. I never said that science fiction authors wrote against science, because this is what you understood. I never said that. I said that there was a period we knew very little, so there was room for science fiction writers to do that. But now we know more and more and more, and the increase in our knowledge goes exponentially. So it becomes harder and harder for science fiction writers to imagine things, unless if they imagine life within a black hole. It's still allowable, I mean. But, okay, there is room, but less and less. That was my point.
I would say that this is similar to the problem of decreasing amounts of big questions in science, because we see specializations getting narrower and narrower, and people focusing on more incremental problems. I'm not sure whether this is, to what extent this is a prevalent trend, because one cannot be familiar with all fields. And also, there still could be some paradigm shifts enabling for more big questions explored by science, as well as in the fictional manner, science fiction. And many of these increases in knowledge could be opening new doors, new possibilities, new questions that we can explore. And some of them might feel like more incremental questions, or, you know, smaller questions than, oh, is there a civilization on Mars? But, I mean, we still can ask about civilizations in the galaxy, around other stars, because we know so very little about whether they could be there or are there. That's actually going to be a big focus of the afternoon talks. So, yeah, there's still a lot of room for imagination.
Thank you very much. I'm afraid I must close the discussion because we are getting a bit late. But thank you again.